6.1 Notes, Laws of Exponents, Day 2. Alright, so today what we're talking about again is the properties of exponents, or also called the laws of exponents. This is what your STAR Algebra 1 reference materials looks like. It's a portion of what is on the materials that you will get to use on the STAR test. If you're in my class, it's the pink sheet that was given to you that we get out quite often. And we have already learned 3 of these properties that are on this reference sheet. On Monday or Tuesday in class, you learned the product of powers property, the quotient of powers property, and the negative exponent property. We also learned another property about exponents, but it is not on the reference material. It is one that you just have to know because it's just a basic math fact, and that is that A, in other words, anything. It could be the variable, it could be a number, anything that is raised to the power of 0 is equal to 1. Today what we are learning is the power of a power rule. And that is actually the only property that we will learn today. Next time we will learn the rational exponent property. So today we are just focusing on one property, and that is the power of a power property. Alright, so the power of a power property is the rule that when we raise a power to a power, we multiply exponent to exponent. So what that looks like. Okay, and I'm going to bring this down here so we have some more room. Is say we have x squared, that 2 is an exponent, but now that whole quantity is being cubed. So we have this exponent raised to another exponent. That's what a power of a power means. Okay, so how we write that out? Well, anytime, let's say this was just like x cubed. That would mean if we had x cubed, that'd be x times x times x. Well, we have x squared cubed, and so that means x squared times x squared times x squared. Okay, so that's what it means. But instead of having to write that out, because, I mean, imagine if it was like x squared to 150. You'd be writing x squared 150 times. That's too much. So that's why we have the shortcut that is the power of a power property. And so what we do is we multiply the powers to the other power. Okay, so we multiply the exponents. So 2 times 3 is 6. So what it is x to the 6th power. So that is our final answer. Alright, so let's practice. It says simplify the expression and write your answer using only positive exponents. Alright, we're going to do number 1 first. I'm going to bring it down here since it's kind of blurry. Number 1 says q to the 5th power raised to the 3rd power. So we have a power of a power, an exponent raised to another exponent. Therefore, we use the power of a power property, which states that we multiply exponent to exponent. So our 2 exponents are 5 and 3. So when we rewrite it, it becomes q raised to the 5 times 3. Well, 5 times 3 is equal to 15, so our answer becomes q to the 15th power. Now let's try number 2. Number 2 says a to the negative 4th power raised to the 2nd power. Again, it's a power raised to a power, an exponent raised to another exponent, so we follow the power of a power property, which again says multiply exponent to exponent. So we're going to multiply our 2 exponents together, and we get a to the negative 4 times positive 2, and then a or negative 4 times 2 becomes negative 8. So we get a raised to the negative 8. Okay, but go back to your instructions. Notice it said to write your answer using only positive exponents. So we have to get rid of that negative 8 by using our negative exponent rule, or negative exponent property. And that property is, remember we have that phrase that says, cross the line, change the sign. Okay, if you don't see the line, that means your term is on top of the line. So right now, our a to the negative 8th is on top of the line. Okay, well, if we want to get rid of the negative, we have to make the base cross the line. In this case, our base of the negative exponent is a. So, equals, we move the a to the bottom, and if we cross the line, we change the sign. So the exponent of a, which is negative 8, now becomes a positive 8. Well, the thing is, if we have a denominator, we have to have a numerator. That means we have to have something on top, and if there's nothing left on top, that means you're left with a 1. So your final answer is 1 over a to the 8th power. Alright, now I want you to pause the video and attempt numbers 3 and numbers 4 on your own, and then you can unpause the video and follow my steps to see if you got it correct. Remember here that this is being multiplied. This is not a power to a power. So now we're going back to the product of powers rule instead of using a power of a power rule. So we've already used the power of a power property. Now we're going back to what we learned the other day and using the product of powers because we're multiplying. And when we multiply with exponents, we add them. Alright, now let's walk through a little bit more difficult problems together. We'll do a couple together and then you'll try a few on your own. So let's start with number 4. Okay, number 4 says negative 4d raised to the 4th power. So the whole quantity of negative 4d is raised to the 4th power. Well, here's the deal. Since that whole thing is raised to the 4th power, that means that everything inside of this parentheses has to be raised to the 4th power. It's kind of like distributing, but you're distributing the exponent. Okay, so we have negative 4 that gets raised to the 4th power. Then we have d that gets raised to the 4th power. Okay, and then negative 4 raised to the 4th power, you can type that in your calculator with negative 4 in parentheses, then your little caret top button, which is located underneath your clear button, raised to the 4th power. Okay, and when we do that in the calculator, we get 256, and then d to the 4th, we can't simplify that anymore because we don't know the value of d. So it just stays d to the 4th, and this is your final answer. Alright, now let's skip over to number 6 and try that one together. Number 6 says 4 divided by x, all raised to the power of negative 3. Okay, so again, just like we had to basically distribute the exponent to everything inside the parentheses, the same thing will happen when we have division on the inside. Okay, so the negative 3 exponent must go to the 4, and it must go to the x. So if we rewrite that, it's going to say 4 raised to the negative third power divided by x to the negative third power. Okay, well, 4 raised to the negative third, that is a negative exponent, and actually x has a negative exponent as well, so now we have to use our negative exponent rule. And again, remember, our negative exponent property says cross the line, change the sign. And what we mean by that is what crosses the line is the base of your exponent. What sign changes is the sign of the exponent. Okay, so draw your line. If 4 has a negative exponent, that means we take the base 4 and cross the line. Okay, but since we cross the line, change the sign of our exponent, so our exponent goes from a negative 3 to now a positive 3. Okay, now look at your denominator, which has x to the negative 3. Again, because it's a negative exponent, we take the base, which is x, and we cross the line. So x is now on top, but because we cross the line, we must change the sign. And so our exponent goes from a negative 3 to a positive 3. Okay, and we're almost done. We just need to simplify whatever 4 to the third power is. And again, you can type that into your calculator with the caret top button. So 4 caret top 3 into your calculator, and 4 to the third power is 64. And then we still have x cubed on top. So your final answer is x cubed divided by 64. And this was actually supposed to be an equal sign, not a z. Sorry. All right, we're going to try one more together, and then I want you to do the ones that we did not do, which would be numbers 5 and number 8, and complete those before you come back to class next time. So number 7 says x to the third power divided by y, all raised to the second power. Okay, so we have a power to a power, and that means we've got to multiply our exponents together. Okay, and everything on the inside of the parentheses gets distributed the power on the outside. Okay, the y, you may not see it, but it has an understood exponent of 1. So now we've got to take our 2 and multiply it by the exponent of the x and by the exponent of the y. Okay, so that simplifies to x, oops, sorry, that's supposed to be an x raised to the 3 times 2 power divided by y raised to the 1 times 2 power. All right, now let's simplify that multiplication. X to the 3 times 2, well, 3 times 2 is 6, so we get x to the 6th on top. And y to the 1 times 2, 1 times 2 is 2, so we get y squared on bottom. So our final answer is x to the 6th divided by y squared. Some of you might ask, well, why aren't we using our quotient of powers property? Because there's division happening. But the problem is here is that our bases are not like bases. They are different variables, so we can't go any further. This is as simplified as it gets. All right, now you try numbers 5 and number 8 on your own, and then you can check it when you come to class next time I see you.